Hello MacroHeart community, welcome back. So today and yesterday I spent a lot of time documenting what has been done so far, like the progress so far for our protocol. So that is the majority of the work I have been doing these days. So other than that, today we'll be talking about a mathematical concept which is important to design protocols and sometimes code, and it's called state function versus path function. So in order to understand that, first we need to understand what is a state. So any system that we observe or that we want to build is actually composed of states. So for example, the room in which I am sitting has different states, which includes temperature, the smell in the room, the pressure, humidity, etc. And these states change with time, and these states as a function of time define the condition of the room. Now similarly, if I want to build a protocol, it is also essentially a system which will evolve with time. Now what will evolve will be certain states of the system. So for example, if we consider Uniswap protocol, this is a smart contract, but the contract is composed of states which are token reserves. So every pair of token has token reserves, and this essentially defines the protocol. Now the next thing that comes in the discussion are state functions. So there can be some functions which are solely dependent on state. So again, taking example of Uniswap, if we take price of a certain asset, suppose USDT versus Ethereum, then the price of Ethereum is calculated as the amount of USDT that is there in the pool divided by the amount of Ethereum that is in the pool. So therefore, at any point in time, the price of Ethereum is calculated by the state of the protocol, which is essentially the reserves of Ethereum and reserves of USDT. Similarly, we have a different kind of function which is called path functions. Now, path functions not just depend on the state of the system, they also depend on the history of the system. That is, how exactly the state was achieved. So imagine some hypothetical exchange where the price is not just simply the ratio of reserves, the price is also the ratio of reserves now and what was the ratio of reserves 10 minutes ago, and then you take average of these two prices. Although such an exchange doesn't exist, but this is only for theoretical purposes. So now we can see that in the first case of state functions, it is very easy to handle prices and predict prices. All I need to know is what exactly is the reserve ratio of the pool, or what exactly is the state of the system. If you give me a state, I will give you the value of the function, in this case price. In case of path functions, I also need to know the whole history of the system. If you just give me the current state of the system, I can't predict the value of the function. So if we take the case of hypothetical exchange, if you tell me what is the reserves of the tokens in the exchange, then I can't tell you what's the value of the price. I need to know what was the value of the reserves in the history of the exchange. Now you can see that in case of state functions, the state starts from a particular point, moves up and down and comes back to the same point. Then value of the function comes back to the initial point. So you can see that the value of the function remains invariant. So as discussed in one of the previous videos, invariance is a good principle to apply while designing protocols. And if you spot a state function in your equations, then you can come up with some invariant, and hence making your protocol and your code more robust. On the other hand, if your protocol has lots of path functions, for example, the capital efficient exchange that I designed recently has a path function. So it doesn't allow us to predict what will happen to the exchange in future, and it makes the protocol's future very non-deterministic, because things are not just dependent on the state of the system, and there can be infinite paths through which the state can change. So therefore I can't predict what will be the future value of the functions in the protocol. So yeah, that was a high level overview about state functions and path functions, and it's a good idea, generally speaking, to have state functions in your protocol because it makes the protocol more deterministic and it induces more invariants in your codes and protocol design, making it more robust. So that's all for today. Hope you find the video interesting and useful, and if you are watching me for the first time, then subscribe to this channel and become part of the Macro Heart community, where we are building the next economy. So see you tomorrow. Until then, bye bye.